Okay, today we're going to look at determining a local max and min from a graph, and you'll want to have your graphing calculator out for this because we'll use that as our primary method for doing this. This can also be found in your textbook, I believe in section 6.7. Okay, so let's say we start out with a cubic function here, which is 2x cubed minus 12x plus 6. Yesterday you would have learned that a cubic function looks sort of like this. This is that kind of sideways S curve. And we notice here that there's a local maximum here. This is where it goes and it stops and turns around and goes back in the other direction. So this would be a local maximum and this would be a local minimum down here. So we want to look at how we can find that using the graphing calculator. So we're going to turn our calculator on and we'll hit the y equals in the top left, and we'll just go ahead and type in that equation, which is 2x, I gotta delete that, it's going to be 2x, which is right here next to the alpha button, cubed, and it looks like I'm still have an extra value in here, so make sure you delete out that stuff. So I'm at 2x cubed, and I may need to delete one more. There you go, 2x cubed minus 12x plus 6, and we'll go ahead and hit graph. Okay, I'm not really sure what my graph's going to look like, but I end up, well, it looks like I can see it a little bit. So typically here, my first thing I'm going to do is hit zoom, and I'll scroll all the way down here, or just hit 0 to fit, okay, because I want the calculator to just kind of estimate where that's going to be. And we see that that gets me a pretty good look at where my graph is. If I want to, I also like using Z box, which I hit zoom and number 1, and then what I can do from there is just kind of highlight. So I scroll up here, put my cursor kind of where I want it, and I hit enter, and I scroll down and I make a box around the area that I want to zoom in on. And again, we want to find this local maximum here and local minimum there. We're going to let the calculator do the work from there. Okay, so now I have a pretty good view at it, so this should be fairly easy for me to get. If you notice, it looks very different than the one I had here on Desmos, and that's just because my window setting is very different. So if I were to zoom in or out on this one on Desmos, that's going to change what that looks like. So don't worry about that not matching up exactly. Okay, so from here I'm going to do a calculation. So I hit second and calc, which is this button right here underneath trace, and I'm trying to find, we'll go with the maximum first. So I hit enter, and it's going to say left bound, so I'm going to arrow over and get somewhere to the left of my local maximum, and then I'll go to the right and I'll get somewhere to the right of my local maximum, and that's just going to bracket in where my answer is. Now some of your graphing calculators won't have these dashed lines, you'll just have the arrows, but it's doing the same thing. And I hit enter, and that's going to give me a maximum here, and those coordinates would be negative 1.414 and 17.313, so that would be my maximum value there. Okay, if I wanted to find my minimum, I'll do the same thing, second and calc, and it's not doing it, so I may have to hit graph again. Go second, calc, and I'm going to pick minimum, which is number 3, and it's going to say left bound, so I'm going to come over here somewhere to the left of my minimum and hit enter, and looks like I'm on the axis, but that's okay, and scroll somewhere to the right, hit enter, and then it's going to give me my minimum value there as well. Okay, so that's finding the local max and min on your calculator. The big thing that you have to play around with is zooming so that you can get a decent view of that in your screen, and there's a lot of ways that you can do that, so just work on figuring out how you can find that so that it's easy to see. Okay, the next problem I want to look at is a word problem with this, and so you can go ahead, I'd pause the video here and read through this problem, see if you can draw the picture and add an X at the unknown values, and then look at how you find the volume of a cube. So you may need to review that formula, fill in your dimensions, and see how far you can get on this. It's not too hard of a problem, but the setup will be different than stuff we've done in the past. So go ahead and take some time and see if you can figure this problem out or get as far as you can, and then ask for help when you get stuck. Thanks.